Okay, Rolla. Hello, Rolla. All right, this is the problem you were talking about. I've got a different number in here. I've used 9. I think your problem was 8. But here's the gist of it, if you will. All right, here's my, hope you could read my writing. But this is the original problem here. And, oh, actually, it's all under one radical, though. So I split it up, which you're allowed to do, of course. Okay? And then I went and substituted the values for it. It said to use the volume as 9 in my problem, and substitute pi with 22 over 7. All right, and that's what I've done in this part here. All right, so if I continue on with this, this will look like the cube root of 3 times 9 is 27, and the cube root of 27 is 3. So I could say that my numerator here is going to be 3, and it's going to be over this cube root here, and I'm going to look at it this way and say this is going to be 88 over 7. And that's the cube root. Put my index there of 3. Okay, so now what I want to do is I want to split this up like I did over here, but I didn't show you. I just wanted to get to the problem. I think you understand that, this part here where I split it up. Or I'm going to split up this denominator now. Okay, and I'm going to split that up so it's going to be 3 over the cube root of 88 divided by the cube root of 7. Okay, I hope you understand this. And now what I'm going to do at this point is I'm going to do the keep change flip here. At this point, this is 3, so it's going to be 3 over 1, and I'm going to keep the 3, change the sign to multiplication, and flip the bottom, that fraction. So I'm going to have up here is the cube root of 7 over the cube root of 88. So far, so good. Okay, so now what's critical here is I want to simplify that 88, that cube root of 88. I don't want to multiply that across yet. Or I could, let's see if I did, but then eventually I will. So I'll put these two together here. It's 3 times the cube root of 7, and this is going to be over this cube root of 88. I just kind of brought these two together so I don't forget that 3. All right, so now at this point, here's where I want to take the 88 and do the what? I want to simplify that, because notice I have a radical in the denominator. And if I do, I'm going to have to rationalize the denominator. So I get rid of that radical sign. All right, so first let's take this 88. I got 88, and what do I want? The cube root of 88. Well, that looks like it's 11 times 8. And I know that the cube root of 8 is 2. Cube root of 8 is 2. So this denominator now is going to become, I'll put it over here. It's going to be, what's it going to be? It's going to be 2 cube root of 11. And my top will stay the same as 3 times the cube root of 7. All right, so these two, was 88, but now it's no longer. And so this is what I'm going to rationalize. Okay, so give me a second here. I want room to write too. And let's go with this, and I'm going to rewrite this to be 3 times the cube root of 7 over 2 times the cube root of 11. And now my next job is to get rid of that radical sign in the denominator. And you can see why I wanted to get rid of the 88. I don't want to multiply by 88. That's too big of a number, so I shrink it down a little bit. Now I have to rationalize the denominator. And now when I rationalize it, I need to get this 11 times what, so it's a perfect cube number. Well, this is 11 to the first, so I could multiply this by the cube root of 11 to the second power, because now I have 3 of them. And that's what I need to do. With the square roots, we just multiplied by another square root, and that was 2 of them. This is 3 of them, and because it's a cube root problem. So now this is 11 to the second power, which is 121, times 11, whatever that is. So there's 3 11s, in other words, when I go to simplify that. The top I'm going to multiply by the same as the bottom, which is, I'm going to put this as 121, because I'm going to have to multiply 7 times 121. All right, so let's see what we've got now at this point. How about this denominator? This denominator, here I've got the cube root of 11 times the cube root of 11 squared is really the cube root of 11 to the third power. So for every 3 11s, you take 1 out. Okay, so this is going to end up being this 2 times the cube root of 11 to the third power. This is just 11. And then my numerator up here, this is going to be, let's see, I've got the cube root of 7 times 121. Let's see, 121 is 11 times 11. That's only 2 11s. I don't have another one. 7 I can't do anything with. It's a prime number, so is 11. Okay, so what do I do with this? I'm going to bring the 3 over here and multiply to what these 2 guys here equal when I multiply them. Same index, different numbers under the radical, so I can multiply them. So this is going to end up being the cube root of, let's see, 7 times 1 is 7. 7 times 2 is 14. Put down the 4, carry the 1. And 7 times 1 is 7, plus 1 is 8. And this is going to be my final answer. 2 times, let's see if I can scooch it over here. So this is going to end up equaling 3 cube root of 847. And that's going to be over 2 times 11, which is 22. And this is your answer. That was a tough problem. One of the toughest. Okay? And I think the real stumbling block was rationalizing the denominator. Remember, that was to the third power, so we needed 2 11s to multiply it together. So I get that out of the radical, which is what rationalizing is all about. Okay, I won't bore you anymore with this, so take care. Hope you're doing well with this virus and all that. I'm going a little crazy, but I'm okay. All right, take care. Talk to you again.